Greetings, this is Axel from the Grade 12 Greatness. I am now here presenting in this video about my chemistry project about electrolysis, which this project is simply called as DIY electrolysis. What is electrolysis? Electrolysis is the process of using electricity to produce a chemical reaction of ionic compounds. The more specific meaning is to split up and form new substances with the use of electricity, coming from the Greek word electrolysis, meaning splitting by electricity. Electrolysis can be used for separating materials, extraction of ores, or removing rust of metals. Metal plating prevents rust and produces gas such as chlorine, hydrogen, and sodium hydroxides. Now moving on to the parts on how do we start an experiment in electrolysis. Now looking at how do we build our component to start electrolysis experiment. We have the power source, which we are using a battery, wires to connect the circuit, compound solution that you are going to use, the beaker to hold the solution, and finally the electrodes, which are the main components of the circuit. Now what is electrodes? Electrodes can be defined as a cells that uses electricity to force otherwise unwilling chemical reactions to occur. In simpler words, they generate an electrical current to force a chemical reaction with the substance, hence creating electrolysis. We are going to start with an experiment which will be split into two separate parts. The first part is a home experiment using the graphite as the electrode, which we use as two pencils, hence the name DIY electrolysis, and using dilute salt or NaCl as the solution we are going to experiment with. Now, in this first experiment, we are expecting in the cathode a hydrogen gas as the product, while in the anode we are expecting oxygen gas as the product. The left electrode is the anode, while the right electrode is the cathode. As you can see in the electrodes, both electrodes here are forming bubbles around the electrodes in both the cathode and the anode. Now, from my predictions, in the cathode, which is the negative electrode, would attract positive ions, which means that it is likely that hydrogen gas is forming around the cathode, while the anode, which is the positive electrode, would be producing oxygen gas. Now for the second experiment, as you can see here, we're in the school laboratory with Miss Mehta and our class, where we are going to make full use of the materials provided by the school to expand our view in experimenting with electrolysis with different materials, apart from the common material used such as salt. Now, we are split into 4 different experiments, and I am now experimenting with copper sulfate or CuSO4 with C electrode at 9 voltage. Now in the apparatus I'm using is a 1 beaker, a 9 volt power source, 2 pencils as the electrodes, 200 milliliter of water, and 0.5 grams of CuSO4. Now in the predicted results at the cathode, we expect to see Cu solid metal to form around the cathode, the negative electrodes, and in the anode we expect to see oxygen gas forming. So the products we are seeing is Cu metal solids and oxygen gas. Now as you can see from this experiment, when we were predicting that Cu solid is supposed to form in the cathode, but we are seeing bubbles forming in both electrodes, Now, as you can see in the cathode, the bubbles are a bit different, react differently from the anode, as it's, from what we're observing, is not bubbles that is forming, which means that we are not seeing gases that is forming, but rather the process where electrodes are shifting between the ions, in which results to have the observation of bubbles forming along the electrodes. After going through these two experiments, we can first deduct that the power source can influence the rate of reaction of the electrolysis, where the voltage is proportional to the rate of reaction, thereby meaning that as the voltage of the power source increases, the speed of the reaction will increase as well. And second, we can also conclude that where our electrodes, which are the two pencils, are graphite electrodes, which are theorized to say they are non-soluble electrodes, as they do not dissolve or break down during the electrolysis process, as which we can see that it shows no signs of being broken down or losing weight. That is all. Thank you for watching this video, and I hope you are able to learn something.